So when we talk about the upstream oil and gas environment, we particularly focus on production units offshore. Right. Now the production units offshore, these are large assets, 24 hours of production. Now if we look at the flare stacks on these installations, these flare stacks burn off a lot of hydrocarbons, a lot of heat going through these flare stacks. Now traditionally, if there's an issue with the flare stack or you're just doing an inspection on the flare stack, traditionally we're going to be using binoculars, and that binoculars is giving us a visual of the flare stack, but it's being done from the ground. It's not a really close visual. If we find an anomaly the traditional way, then we need to make a decision about, are we going to hold production for a certain amount of time so we can get an access team up there to look at this flare stack, or are we going to continue production? So that's the traditional method. So when drones have now been introduced, this changes the dynamics a little bit. We can now get a drone into the air pretty quickly, and we can get close to this flare stack without shutting down operations. We can take high resolution images, including thermal images of this flare stack. Now what does a thermal image do for me that a normal RGB image cannot do? Well, a thermal image is doing exactly that. It's creating thermal signatures or capturing thermal signatures. So a thermal signature on a flare stack will just be a difference in temperature. Right. So the higher the temperature, it's going to come up in a certain color. The lower temperature will be a certain color, and we'll straight away be able to see on a thermal image where we have large temperature differences on our flare stack, and we can even read the temperatures. If I focus on the flare stack with my thermal imaging camera from a distance, I just tap on the screen and it'll actually tell me what that temperature is at that point in time. Right, so the benefit of having a thermal imaging camera, and we also have an RGB camera side by side, so every thermal image we take of the flare stack, we take a normal JPEG in high resolution. So when we give that data to our client, or to the OIM in this case, they can now see there's been a thermal difference in temperature on this flare stack, and that might mean trouble, it might not, they will know best. But then at the same time, they look at the thermal image and they can straight away see on the normal RGB or JPEG image where the anomaly is that they are picking up. Now they can make an informed decision about what they want to do next, right? And they can do it with clear, concise, factional data, right? So also the drones don't need to be super close to the flare stack to do this inspection. People tend to think the drone flies nice and close, 10 feet away. That's not how it's done. We actually can fly 100, 150 feet away from the asset, actually flying over the ocean, and then using high resolution zoom cameras with the thermal and zoom into the asset and still get high resolution. So we're not flying close to the asset as to endanger the asset per se, right? So we're at a safe distance, keeping people and the workforce safe, and that is key as well. But the key thing is we get data that is clear and concise, that helps the OIM and the maintenance and operation team make a clear decision about what they want to do next after they've done the inspection. Now the inspection just doesn't have to be ad hoc. We can carry out the inspections, on a monthly, quarterly or yearly basis, or be called in if there is an anomaly found. Right, but the data you're getting from a drone in the air, zooming in and using thermal imaging, is going to be a lot more clear than the old style way of doing it from the ground with your binoculars. So that is how we can utilize drones and drone technology, particularly in the upstream environment. Right. So next, let's have a look at the midstream environment and how drone technology can help us over there.